Hi, good evening. Today I'm going to explain how you can set up an ELK stack, meaning Elasticsearch, Logstash and Kibana, as your login solution on Azure. Uh, by going to my GitHub repository, you see the steps, the documentation I made, and there's also a little picture I will use for trying to explain what's going on. So, what am I doing here? I've created a script that creates an Elasticsearch machine, one machine, singular, and every time you call the script with new parameters, it will create another machine in that cluster. And so what we basically do is we have a mechanism to create a separate virtual machine that will be part of an Elasticsearch cluster on your Azure VNet. All these machines will be in the same VNet, which is defined in the template which has been used to create the Elasticsearch machine. In the second part, we will create a Kubernetes cluster, and on this Kubernetes cluster we will deploy Logstash and Kibana. For Logstash, that will be the mechanism for the ingress for the applications. So basically, an application logs stuff to Logstash. Logstash parses it and will persist it into the Elasticsearch database. The Kibana stuff will be also deployed on the Kubernetes cluster, and it's a nice front-end tool to query the Elasticsearch database for relevant data. Both services will be exposed to a public IP, and what I will do is just create a simple Kubernetes cluster and not secure it. But if you like to secure it, please spend some time in investigating in the XSpec of the Elasticsearch guys, because with that XSpec you can secure your Logstash or your Kibana. So the Kubernetes cluster will be created in a separate VNet as well, and in order to communicate to each other we need to have VNet peering. I created a script for that as well, and all the communication will be done through internal load balancer, Azure internal load balancer, which will be available at 11.11.0.100 at port 9200. This internal load balancer will load the data between the availability set machines of the Elasticsearch cluster. So let's get to it. Let's see what we are doing here. Okay, one more thing. I also created a Java application which is made with Spring Boot, and this application contains Log4j properties which are configured to talk to this service. Yes, so I will show you how to do that as well. Let's get started over here. Let's start by creating an Elasticsearch machine. We go to the repository, we go to the Elasticsearch directory, and here you see there is a script called create VM. Assuming you're already logged into your CLI, what you do is you go to Elasticsearch, you create VM. Okay, we will do this demo in one resource group, ELK demo. I'm not logged in here. So I just logged myself in. Doing it again. Create VM.sh. Look at ELK demo. Now I need to define a node name, Elastic1. So I made this script this way that it will use the resource group name and this node Elastic name as a node name. So it will be called ELK demo Elastic1. So this will take a minute or two. I will create 2 machines in the meantime, and when I'm done I will be back. So just finished creating my second machine. Let's have a look in the Azure portal what we just created. I created 2 machines in the same resource group named elk demo, and here you see my machines, Elastic 1 and Elastic 2. So if you have a good look at it, they are in the same availability set, which will be of use later on. What we want to achieve is that we now have a cluster, or that the machines are part of an Elasticsearch cluster. So we can do this by using an example. Let's have a look. This is the configuration we're going to use. We're going to paste a similar configuration on each machine. I didn't automate this. This is maybe something we can do later on. But what I need to do is to log into each machine now. I'm becoming root over here. And I'm going to edit the Elasticsearch configuration file. I'm going to the bottom. Oh, and this is not the stuff I want. Let's go back here. This is the YAML file. Or this is not a YAML file, a configuration file. So let's paste it here. I'm going to name the cluster elk demo. This machine is called elk demo elastic 1. This is something that the documentation said you always have to set, so I'm doing this. And here I'm putting the machine names. Mind, don't use the port number. So my cluster will consist of 2 machines, elk demo elastic 1, elk demo elastic 2. The next thing I need to do now is restart Elasticsearch. Restart Elasticsearch. Let's see if that went fine. Status. So that all went fine. Let's do the same thing on the second machine. Elastic 2. Here we go. Copy. So this one will be the second. Yeah, this one can go. I see I missed 2 properties here. I will make that part of the documentation as well, or I will. Okay. Let's restart systemctl, restart Elasticsearch. Let's see if that is okay. That's okay. Let's see if the machine is listening on port 9200. It's listening on 9200 but on localhost, and that's not something I like at the moment. So what I will do is I will change the configuration. Network. I will add these properties in the example, so you don't need to do that anymore. Apologies for this part. I will say it will listen on all interfaces on port 9200. Let's restart again. That went fine. Let's see if it's now actually listening on. Yes, so this is fine. Let's do that on this first machine as well, which we forgot. Okay, let me just copy this part in the example, so you don't need to do that anymore. Next time, 0.0.0.0, so. Interface. So, that's fine. Now we want to see if the cluster is doing what it should do. So I can do a curl on this machine, HTTP on port 9200, and I can say cluster and health. One moment, please. Yeah, that didn't work because that is the public IP address and there's a network security group on it, and we don't want to communicate with the public IP address anyway. So that's what I showed you in my first drawing. We create a internal load balancer now. So I create a little script for that. Create LB load balancer. I have to fill in the resource group. It's elk demo. It will list the virtual networks. No, this will just create the internal load balancer. Okay. So let's have a look. What did it create? Load balancer type. It created the Elastic LB load balancer. This is one part I was not able to script. I have to find out how to do it. But what I need to do is, as a last part, is I'm going to the Elastic pool and I have to add virtual machines. I'm choosing the availability set. I created this availability set and it contains the two machines I just created. So there we go. Okay, saving it, and we will have a load balancer now which will be available internally with this IP address 11.11.100. So let's go to the second part and create our Kubernetes cluster. So You can create it with the Docker file, or and just pull it from the Docker Hub, as I already pushed my image here, and the image it's in the README file as well, but the image name now it's called elk demo cube 1.0. So I'm going to do a docker run -it in bash. I'm going to opt QB, and I'm going to create an Azure account, which I will be using in my demo here. Create Azure account. Don't need any data collection. Logging in here. Hop. Logged in. I'm going to call this elk demo 666. I'm going to use this account. So in the meantime, I'm going to the portal, going to the Azure Active Directory. Going to application registrations. Please mind that your account you're using should have Azure AD permissions for this. So it should have the role to have password role. So you should be able to create accounts essentially. So you see here I created the elk demo 666. Bad number. ACS key. I will say it will last for 2 years, and I will save it. Copying the key over here. I'm editing the config cluster here, and this is the secret. The client ID corresponds with the application ID. You will see here in the portal as well. Copy it. Oh. That's fine. I need to log in now. Log into Azure. It's using the certificate in combination with the credentials we just created. So let's configure the Kubernetes cluster. I'm going to pause because this will take a couple of minutes as well. So it's done configuring. Now I'm going to actually create it. So please do mind that Kubernetes will be a managed service soon, so you don't need to do all this stuff. So that's great news actually, because you don't need to maintain the machines anymore. Create Kube cluster. So the resource group name, I'm changing it here to elk demo, and then I'm calling the create Kube cluster. And that will take a couple of minutes as well. So let me pause again. It's done creating the Kubernetes cluster. You see at the bottom you see a command. I'm executing this command. It's basically copying the configuration file of the master to your local machine, which is possible because you exchanged keys. And because I've done this, I can execute on this Docker image the Kubernetes commands for showing the nodes, for example. Get nodes. So my Kubernetes cluster consists of 3 machines at the moment and 1 master. And if correctly, no pods, get pods, min o white, nothing, namespace is Cube system, and I will see some stuff appearing, but that's Kubernetes internals. So let's not go there. So like I showed you in the beginning of this demo, I showed you a picture that we now basically have 2 networks. We got one VNet which contains the Elasticsearch machines. Let's go here, virtual net. So this is one VNet. This contains the Elasticsearch machines, and we got this VNet, which contains the the Kubernetes cluster. So now we need to link them together, and we can do this with a script I created by creating a peer. So let's go to the Kube directory. No. To the VNet folder, and in the VNet folder I have a script called create_vnetpeer.sh. It will scan for the virtual networks in this resource group, and then it will say which VNets would you like to link to each other. The order doesn't really matter, basically. I'm saying this one to this one. Basically I'm using ARM templates for this, and I'm substituting some values. Have a look at the scripts. It's very easy and it's fairly quick to run. So what I achieved here is when I'm on my Kubernetes master, let's just wait till this is finished. Please see that I'm using the Azure user, which is being used in my script. With this user I can just log into the master. And yeah, it's done. If config -a, you will see that the master has an IP address in the 10.240 range, and my Elastic machines are in the 11 range. So what I would like to see and test is if my load balancer is available from here. It's not yet, so I will have to wait a while, probably. Just pausing because this can take a couple of minutes to activate. So it took about 2 minutes, but what I can do now is I can, from my Kubernetes master, I can reach the Elasticsearch machines. Ping 11.04.5, so this is cool. As you might remember, I also created an internal load balancer. So if I do a telnet 11.11.0.100 on port 9200, bingo. So now the ultimate test, I'm going to do a curl on the load balancer, HTTP, and cluster health. And here you see that the number of nodes is 2, which is excellent. So, and that's all cool stuff. Now let's go to setting up the Logstash part, which will be the ingress for the Java applications. So I'm exiting my Kubernetes Docker instance. I'm going to Logstash. Let's see. Yeah, I created a Docker file here, so you can create your own Docker image. But I also pushed mine already to Docker Hub, so you can also use this existing one. The only thing which I made configurable now is in the conf directory. I said there is a logstash.conf file, and I'm saying this is the configuration of my current Logstash, because in this demo I only have log4j, and I'm writing my configuration to a predefined load balancer which we just created on 11.11.0.100 on port 9200. So Logstash is taking log4j input, parsing it with some kind of filter, and then it will write it down in Elasticsearch on this remote host. That's that. If you have a look at the Logstash app.yaml file, this will be the stuff I will be using for deploying it to Kubernetes. So what I will do is kubectl create -f conf Logstash. Oh, Logstash -up. Aha. So what happened here is I Docker created my Kubernetes cluster. With a Docker image. And from that Docker image I exchanged keys, but the keys are not on my local machine yet. So let's go again to the master. In the master I will say I'm accepting keys from my machine, and the key from my machine is SSH ID RSA.pub. Copying this one, and I'm going here to SSH authorized keys. Yes. So, okay. Exiting the master. I will need the URL of the master, just to be sure. Yes, this is the complete URL. So going back to my local machine again, not my Docker instance, I'm saying I like to copy from this machine as Azure user. I like to copy the .kube config file, and I like to copy it on my local drive. Oh, config. So now I can do cool Kubernetes commands on this machine as well. Get nodes. And that's needed for my deployment. So I'm going back to my Elasticsearch. Oh, sorry, my Logstash. And I'm going to say kubectl create -f logstash up.yaml. Kubectl get pods min-o wide. So it's busy creating the pod. You don't need to be waiting for this. So it's running. Now I'm going to create or expose this as a service. So this is not secure or whatever. Have a look. Oh. This is just a method on, or one of the methods on how you can set up your Kubernetes or Elk stack on Azure, but of course there are multiple scenarios possible. Kubectl get service. So we have this service exposed, but not with an external IP address. This reminds me, we don't want our Elasticsearch machines available through the internet as well. So what we do is we're going to Elastic1. I'm going to this IP address, public IP address. Oh, let's go back. Let's go to the interface, then go to IP configurations, and in the IP configurations we select the IP config, and there we say public IP address disabled. Saving it, because for the Elasticsearch we only like to use our internal IP addresses. So let's do the same thing for the second Elastic machine. Elastic2, network interface, we go to IP configurations, IP config, and say the public IP address is disabled. Sorry for that. So for the Logstash we want to expose the service. So we do edit elk demo Logstash, edit service, and there we go to the part which says cluster IP. I like to have it of a part as type load balancer, and now when I do a kubectl get service and I do a watch in front of it, it is pending and it will create a Azure resource for a public IP address for the Logstash. I will do the same thing for Kibana as well. Let's just wait for a while for this. I will be back when the public IP address is created. So in a while you will see the external IP address, and it means that you can use in your application you can use this IP address and this port to use as your Logstash ingress. So let's forget this for a while. We will do this later in our Java app. Let's go to the Kibana part. We go to Kibana up YAML. Here the same stuff. We say this is the database Elasticsearch. So you don't need to change anything here. You can change it. You have the Docker file, but you can also just use this one because here you see I'm not. It's not even my image. This is the image from Kibana self. It's version 4.6.4. That's fine. Let's do kubectl create -f Kibana up the YAML get ports min all white busy. Yeah, let's wait again. So it's running. Let's expose it again. Expose service. Cut. Expose service. Expose service. So watch kubectl get svc pop. So let's wait till that is done as well. Pause. So in a while we already have the external IP address as well. Let's check if it's available on port 5601. Going to port 5601, and there you go. You will not see anything yet because nothing has been logged yet. There are some commands for that, but let's just do it properly with the application, right? So let's go to our final part of the demo. Let's go to an application I created, very lame, but it's a Spring Boot application, so no JBoss or WebSphere or whatever is needed. We need to configure the property file. The property file is in the resources folder, and here you see I'm referring to a remote host, and this is my Logstash machine. So let's type the kubectl get service, and I see that my Logstash is available at this external IP address on port 5000. Remote host. So let's remove this guy, go to this guy. I'm using Gradle for building my stuff and dependency management. Gradle build. Yep. Of course I can deploy this one on Kubernetes as well, but for the sake of time I think you guys have seen enough of this demo. You see here is the Kubernetes file for deploying it, but let's just run this file. Java min jar. It's in the build lib. So I'm running it locally. So internally it starts some kind of Tomcat or Jetty engine. And if I go now to localhost on port 8080, I'm seeing a message here. I'm logging this stuff, hello world, nothing fancy, and this message should be persisted in Kibana through Logstash as well now. So let's see. Oh, what did I do? Discover. Okay. Let's see if I got a message in anyway. I can exit, get pods, kubectl logs -f, and I'm logging the Logstash. Logging. Here I just see that something has been written to Elasticsearch. So I should be able to, let's just create, discover, yes, that's fine. And here we go, I see my message here saying add. So it logs some more stuff as well. It needs some tweaking and tuning, but anyway, you will see messages. Let's do it again. Hop. You see, I'm getting I got the JSON parse failure. So basically, it's communicating to Logstash, but I made some kind of error in the configuration of my logging. So I will have a look at it as well and fix that. One moment. So fixed a little issue here in my config file of the Logstash, and I will of course push this in my repository as well. My previous input was based on a demo app I made in Node4j or Node.js, and this one is for Java input. Very simple input, but when I do a tail on my Logstash, I'm going to my wonderful app here. You will see it parsed this message, and when I go to Kibana and I want to view this, I see the two messages coming in here. So this was the end of my demo. Hope you guys liked it. Enjoy. Have a nice day.